Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So this is a problem from IMO 1966. Let ABC be a triangle, and let PQR be 3 points in the interiors of the sides BC, CA, AB of this triangle. So we have triangle ABC here, and we have PQR here. Prove that the area of at least one of the 3 triangles AQR, BRP, CPQ is less than or equal to 1/4 of the area of the triangle ABC. Basically, it's saying that the minimum area of triangle AQR, triangle BRP, and the triangle CPQ is less than or equals to 1/4 of the area of triangle ABC. Right. So for this problem, the first thing we can think of is that we give a ratio for each side and calculate for the area of triangle PQR. And we just need to prove that the area of triangle PQR is larger than quarter of area of the triangle ABC. Then we just proved that the 3 areas, the summation of the 3 is less than, so if the area of triangle PQR is larger or equals to 1/4 of the area of triangle ABC, right? That means the summation of let's call it 1, 2, 3, right? The summation of these 3 triangles would be equal to 3/4 of the area of triangle ABC, which means this would be true, right? That's the first thing we can think of, but that's not a very straightforward way to solve this problem. I mean, it's not the easiest way, not the straightforward way. So another thing that we can think of is that because PQR are on each side, so we can calculate for the area of the triangle the area of triangle AQR, BPR, and CQP, right? And we can assume that the minimum of these 3, or the area of these 3, all of them larger or equals to, or larger than the area larger than 1/4 of the area of the triangle ABC, and we find the contradiction, then we prove that, right? So that one sounds easier to do. So let's calculate the area of triangle ARQ, right? The first thing we need to do is to find a better way to divide each side. So for this problem, the easiest way is that we consider the ratio BP to PC equals to A to 1 minus A, right? And we can set CQ to QA equals to B to 1 minus B. And AR to RB equals to C to 1 minus C. right? We can do that. That's the ratio. So the area of triangle ARQ equals to the area of triangle ARC to the area of triangle ABC times the area of triangle AQR to the area of triangle ARC, which equals to AR to AR plus BR, right? Times this one, AQR to ARC, which is AQ to AC. So it equals to AR to AR plus BR, so that is C, and AQ to AC. AC is, so AQ is 1 minus B, right? So 1 minus B. So that's the area of triangle ARQ. Similarly, we can get the area of triangle BPR equals to we calculate for this one first, right? Now we calculate for this one. So it equals to BR to AB times BP to BC, right? So it equals to 1 minus C times A, right? And the area of triangle CPQ equals to CQ to AC. Well, actually, here should be the area, this one to ABC, this one to ABC, right? This one to ABC. It's not calculating the absolute area, it's a ratio. So the ratio of CPQ to ABC is equals to CQ to AC times CP to BC equals to B times CP, which is 1 minus A, right? And we know that because C times 1 minus C or A times 1 minus A or B times 1 minus B, all of them should be less or equals to 1 by 4, right? Because B and plus 1 minus B equals to 1, right? So we know that when these two terms are equal, we get the maximum of the production to be a quarter of the summation, right? So we get B times 1 minus B less than or equals to 1 by 4, which means if we multiply all of them, we have ABC times 1 minus C times 1 minus A times 1 minus B should be less or equals to 1 by 64, right? And here, we have the assumption that each triangle to the total triangle area would be larger than, because we want to prove this one, right? So we assume that all of them are larger than 1/4 of the area of the triangle ABC. So the ratio would be larger than 1/4, larger than 1/4, larger than 1/4. Then we product all of them, we got that ABC times 1 minus C, 1 minus A, 1 minus B larger than 1 to 64. Right? That's a contradiction. And then we have the conclusion that our assumption is incorrect, which is that all of them larger than a quarter. Which means at least one of them, right? The minimum of them would be less than a quarter of the area of triangle ABC. Okay. So this is a problem for, this is an IMO problem, but I don't like this kind of the problem. It's basically not a skill for the geometry, it's a skill for the algebra. Okay, anyway, I hope you like this video. See you in next one. Thank you.